Because I found that, like, using the COVID examples, the numbers are so small that it's hard to fucking get a grasp of what's going on. But I liked using COVID numbers. But we're saying no to COVID numbers. Had good data. We're gonna make some shit up. Today we finally start statistics. All that shit you've been doing for fucking 2 months has just been getting the skills you need to do fucking real statistics. Today we start with inferential statistics. Chapter 9. Aren't you excited? You finally, like, all this fucking calculator shit, learning probability, relative frequency, proportions, mean, standard deviation, it's all finally going to be put to a use rather than just doing stupid shit and plugging in numbers on a computer. We're going to apply it to real life stuff. Of course, I'm going to completely make up today's examples because the numbers suck for the example I got right. So inferential statistics are, well, is the process of trying to infer something or infer something about the population based on data collected in a sample. Infer, if you need like a working definition for this, make an assumption. Okay. So let's say I ask students about ask groups of students if they use TikTok. TikTok regularly. And I'll let them decide what regularly is. Let's say we had 3 groups. The people that said yes will be the first row. the number of people asked, so the sample size. What do next? Let's say in the first group, I asked 60 people and 35 of them said yes. Second group, I asked 40 people and 30 of them said yes. And maybe we'll do 50 and this group had, I don't know, 33 said yes. So what is p hat? Or what's p for each of these? P hat is x over n. And we'll do the 3 decimal places. This is, of course, 35 over 60, 30 over 40. I can do that without a calculator. That's 0.75. And 33 over 50 is 0.66. I don't know what 35 over 60 is. 0.583. And we'll do 2 decimal places because all the others had 2 decimal places. We'll use 2 on this one. Which one do I use? What do I use to describe the population of students in general? What percentage should I use? Why? Why do you say that? So use the one that says 60 because it's got a larger population or the larger sample size? Yeah. That's not a bad idea. I kind of like that. I wasn't expecting an answer, but that's a good answer and it's well thought out answer. Let's go with group 1. Can we use group 1? We started with the largest sample. Seems like reasonable. We're going to say it is. P hat equals 0.58. And that one had 3 repeating, so I'm going to use that. Now, clearly that's not a given because I had 2 other groups with different numbers, right? So like maybe I need to come up with a number range. Let's get a range of, like this is 58.3%. 58.33%. Let's get like a range around it. Well, what's a good way about going about this numerically? If this follows a normal distribution, we could use the normal probability model. Does this follow a normal distribution? Let's check. The criteria we had was n times p times 1 minus p needs to be greater than or equal to 10. And n needs to be less than 5% of the population. Now, clearly 60 is less than 5% of the COS student population. This one, we don't know n, but we know n is way the fuck bigger than 60. It's like in the 10,000 range. Well, what about this one? We had 60 times 0.58. We'll use 2 decimal places for this, just to do this calculate this check. We need to see, is that greater than or equal to 10? Where's the sweet spot? Right there. 60 times 0.58 times, I'm going to use parentheses, 1 minus 0.58. Equal? And I get 14.6 is good enough. That's bigger than 10. We meet the normal model. I'm not certain this is how they came up with this idea, but let's just work this play. Let's play along. So this follows a normal distribution, which means we have a mean for P and a standard deviation for P. The mean for P is just P. So 0.583. It's equal to P hat. This one is that lousy formula, square root of P hat times 1 minus P hat over N. I'm going to do 0.5833. Get a little more accurate for this. Over 60. So I want square root. I'm going to do parentheses. 0.5833 times another parentheses. 1 minus 0.5833 and the parentheses divided by 60 and end the big parentheses. I'm getting 0.0636. Now, 3 decimal places, 6 feet, 0.64. Are you guys with me so far? Of course, these numbers are completely made up. But this is going to present, I think, how they maybe that way that it came up the idea with how they use this. All right, so we got it. We found it follows a normal distribution. We took advantage of that. Let's draw our bell curve. We've got mean in the middle. This is our 0.583. Rather than calculating these out, I'm going to just write mu plus these because I think this will help get the idea of what we're doing, and then we can use the computer to do all the hard work. That froze. Write this down real quick. Okay, so maybe I'll write out the 3 going out 3. There's a lady on the other side of the hallway. It's just staring in here. It's fucking creepy. Oh shit. It's pretty big. This is 0.775. .391. You know what? I'm gonna put in the other ones. Plus 0.064, 0.647, plus 0.064, 0.711, 0.519, 0.455. All right, so turning this into percentages, 39.1%, 45.5%. This is about 52%, 58.3%. I'm gonna round when it gets close. 64.7%. That's about 71%. And that's 77.5%. Okay, so we had 58.3%. That's what we found. But we saw numbers, the other 2 groups were bigger than that. If we could have picked other groups and we have smaller than it. There's got to be some range around this. And so how do we pick it? The narrower the window is, so here's some ideas to think about. The narrower the interval or range, the less likely it holds the actual proportion. So if we make it too small, we're unlikely to capture a whole lot. But if it has it, we are really close to knowing its value. It's got to be right around 0.583. Let me give that a second to sink in. Like, let's say we do plus or minus 1 deviation. That's not a whole lot. And I'm going to use the empirical rule for this. The actual values we'll cover today, but empirical rule, that captures 66% of the area. And we would have a range of 51.9% to 64.7%. Like a plus or minus is basically we're within 6%. What if we go big though? What if we go 3 deviations? Like 3 deviations covers a lot of this picture, right? Plus or minus 3 deviations. Was that 99.7% by our empirical rule? And we would have our interval would be 39.1% to 77.5%. This is a big percentage of the area. There's a good chance when we've got something this big that our bell curve actually captures the real number. So what's the trade-off for having this really big percentage? What's the trade-off for using a bigger region? We're much more likely to capture it. To contain the true proportion. But look at our interval. Is 39.1% to 77.5% a helpful range? One's way the fuck below half and the other's over 3/4. This isn't all that helpful. Got a second to sink in. Okay, so would you be happy with 39% to 77% as a, my grade is somewhere in 39% to 77%? No, I thought let's apply it to something you can relate to. This is not like, we probably have the actual proportion, but we have no idea what it is. The interval's so fucking big. So there's a trade-off here. These are called confidence intervals. And the percentage area we capture is what we call our level of confidence. And the way they work is we make a statement of confidence. Make a statement of confidence. I'm gonna do it based on the big one we got with the empirical rule. So we are 99.7% confident that the true proportion of COS students who use TikTok regularly is between 0.391 and 0.775. Alternatively, for proportions, you could say for proportions, we could say 39.1% and 77.5%. But if we're going to do percentages, we have to include the percent sign. If it doesn't, if you see this and you don't see a percent sign, you have to assume it's not written as a percentage yet. Okay, you guys ready for a little bit more? Nope. Angel looks like she's still writing. It's okay.
Thank you so much.
We're just doing 9.1 today. And it will probably, like, if we want to do it right, we'll do some examples from the homework as well, but to make sure everyone's like down with OPP, we're gonna like spend some time on this. This is like this is crucial though, like getting what's coming next. So I'm gonna go back and I'm gonna find the mean and standard deviation for the other groups. We just did this one. This was 0.583. And we had 0.064. I am doing this calculation right here for all of these. Mu of P is just the proportion. That's the easy part. So group 2. We've got 0.75 times 1 minus 0.75 divided by 40. And sigma for P3 is going to be 0.66 times 1 minus 0.66 divided by 50. I'm gonna get these standard deviations and I'm gonna fill them in, and then that's gonna help us like present this idea a little bit better. Three decimal places for each of them. Oh, 6, 7. Look at that. They're all really fucking close to each other. I write down the range for each of these too. This is 0.861. Something's off. 0.66 plus 0.067. Nope, I wanted minus. There we go. That'll be that group and this group. And this is all for plus or minus 3 deviations I'm doing right now. 0.546. And 0.951. Holy crap. %54 to 95%. F to A. That's a fucking big range. So that was P2's group. P3's group. P1's group. What did I have for P1? Get all these numbers on one page. Point 391. 2.775. This was P equals 0.583. P equals 0.66. And P equals 0.75. Okay, so we're gonna put this all on one number line. See what I can do. My lowest number is 0.391. We'll say 0.40 over here. And over here, we'll say 1.00. Let's see, halfway would be 0.70, 0.50, 0.60, 0.80, 0.90. Now, knowing the three ranges for the plus or minus three standard deviations, make it so I can draw their bell curves on this pretty easy. 391 to 77. Group one had a bell curve. That was group one. Hovering right over 0.583. Group two was 0.54 to 0.95. I don't know that I centered that very well. So this will be group two. And group three was 0.459, which is right about here, to 0.86, which is right about there. Oh, this is over 0.75. Yeah, this should have been more. The green should be a little bit more to the right. Notice there's a lot of overlap. It should be, based on the intervals we picked. What does this confidence interval mean? These were all 99.7 based on empirical rule. It's not the actual value, but based on empirical rule with three deviations, we had 99.7 as our confidence interval. 99.7%. I'm going to call confidence interval CI. %95% is going to be pretty close, almost same as this. So I'm going to give an example with 95% because I think the number is going to work a little bit better for doing it. A 95% confidence interval says that if we repeat this, if we do 100 surveys, I want to make sure I say this to you right. Ninety-five of them, approximately, will contain our p hat. 0.583. What it doesn't say, let me let you finish writing because I want this to be crystal clear. Okay, a 95% CI does not say that there is a 95% chance that we contain the true proportion. It's easy, it's natural to want to interpret it that way. But there is either 0% or 100% chance it contains it. The proportion is fixed, we just don't know what it is. So we in general are never going to know we actually have the percentage right. We even have the right range. Now, for a 95% confidence interval, if it contains the true parameter, this applies to mean that we're going to do on Thursday. We have a normal sample. If it doesn't contain it, we are outside of its 95% region, and thus we have an unusual sample. This is a lot of talky today. And then let's take a 5-minute break and give people a chance to stretch your legs, go to the bathroom. All right, so I'm going to go back to our example with the p equals 0.583. And we had, for plus or minus 1 deviation on the empirical rule, we had 0.519 to 0.647. And our 0.583 is right in the middle. So important things to know. This distance here and this distance here are identical. They're both called E. And E is the margin of error. You can find it. Oh, let me give some more names here. This is called LB stands for lower bound, which the computer calls lower limit. And UB stands for upper bound. And the computer calls that upper limit. Actually, they just say L limit and U limit. The margin of error is equal to P hat, absolute value of P hat minus one of them. LB or UB. I will show both here. 0.583 minus 0.519 in absolute value. Remember, absolute value means make shit positive. I'm getting 0.064, which makes sense. We already calculated that equals 0.064. I picked the numbers because I already knew what they damn well were. If I do 0.583 minus the big one, you're also going to get 0.064 when you do the positive amount. So that's called the margin of error. This full distance here is called the width. The width equals 2 times the error, or it's the upper bound minus the lower bound. Gurgle, gurgle. Oh, so here's some fun information. I had my wisdom teeth, the upper ones taken out on Friday at like 10:30 in the morning. I was out of the dentist's office by like 11:45. And my wife drives me home. I'm a little drugged up. They did the IV, knocked me out. The dentist did the IV himself. He did a better job than most nurses fucking do. He's fucking really skilled with that shit. I guess he does it all the time. They were supposed to prescribe, for some reason they did ibuprofen. They were supposed to do ibuprofen and like codeine or some sort of narcotic. CVS takes their sweet ass fucking time. CVS pharmacies like up at like 8 p.m. or some shit on Fridays. Didn't have it ready. They were having problems. So Saturday morning we go and get it at like 11 o'clock and they only had the ibuprofen. Now, I wasn't hurting yet, but it had been like 24 hours. And I heard like the real pain like starts on like day 2. Well, that was Friday, 5 days ago? I haven't taken a single fucking drug. I have not had like fucking every day. I've had soreness, but I just fucking toughed through that shit. Nothing that I would call like fucking pain. Like everybody whines about how painful the wisdom teeth are. You guys are a bunch of sissies. That shit was easy. Nothing. It's fucking crazy. I did get a bottle like 15 pills of hydrocodone out of it though. Because I called that fucking dentist. I called his office, it was closed. It was like, do you want the emergency? Hit star or whatever. I fucking hit star. I called him like as soon as I got home from CVS. I wasn't hurt yet, but like I didn't want to wait till 10 p.m. And then all of a sudden I was in fucking sheer agony. And the pharmacies are closed and I can't get hold of the doctor. I'm like, nope. Better safe than sorry. It's not my fault. Your fucking dental assistants didn't call in the prescription for it. So they called him at home and he called one in. It's fucking awesome. I didn't get fucking any pain. I don't know what the big fucking hype is. All right, that was fun. All right, so common. These are the common. You're still writing this shit. Holy shit. I told a long ass fucking story.
I know.
You already knew the story too, so it shouldn't have been that distracting.
I didn't know how it ended. And
Oh,
I was so
yeah.
glad that
You
did
didn't,
not
you're
get it
right.
right.
All I remember when I had mine done is I woke up, I had gauze on both sides of my mouth. And
The gauze was the most annoying fucking thing.
yeah, gauze, yeah.
The fucking dry mouth from hell.
Yeah,
And like he gave me a bag of gauze and like I was like drugged up on the way home. And so like when he said change it every 30 minutes. And so I'm like pulling them out and fucking pulling one out and folding it out, stuffing it in. I look like a fucking squirrel with fucking acorns in my mouth for like 2 hours. And then I'm like, my head clears up enough and I actually like look. I pay attention to what I'm doing rather than just grabbing gauze. And I realize he's giving me 3 different fucking sizes. And I've been grabbing the gauze that's like big enough to wrap your fucking leg in.
jeez.
Like it's a big old, like if you had a big old cut on your leg, you would use like a knife wound, you'd use this big ass gauze like that. I'm folding that thing up, so of course I've got a fucking chipmunk face. And I switched to the smaller one and it was much easier. These things are fucking bomb though. Chocolate milk, lactose free if you have problems with lactose. Only 2 grams of sugar, so it wasn't highly sugared. And it fucking actually tasted good for only having 2 grams of sugar. Who would have fucking figured? A lot of protein in it, but it didn't. It tastes like chocolate milk for the most part. All right, so she's done. She's on her calculator. No, she's on her phone.
No calculator.
Okay.
I don't understand. I wrote something down wrong. I wrote just the core figures. And I wrote them down
Which part?
right there, right.
Right here?
Yes.
So do 0.583 minus 0.647 in your calculator. It should say negative,
Yes.
but we make it positive from the absolute value signs.
Thank you.
I'd rather you know what the hell we're talking about than
I appreciate it.
go on without you. That's just lame. All right, so frequently used confidence intervals. In fact, when you're working on your homework and it says here's a fucking table, it's probably going to give you these in case you wanted to calculate them by hand. A 90% CI corresponds to plus or minus 1.645 standard deviations. I need to write the percent. 95% CI is plus or minus 1.96 deviations. And 90, we don't normally do 99.7. We don't use the empirical rule when we're doing this in general. 99% is 2.575 standard deviations. Calculated the same way. Once you have the mean and the standard deviation, you just go through that calculation. Set this up so I can have fresh numbers with you guys. While you're writing that. Does the confidence interval kind of make sense? We want to come up with a range of numbers like around the value we got. But if we make it too big, it's like now unwieldy, it's unusable. If it's too small, it's like we probably don't have the actual parameter. So there's like a balance check to do in there. Because RP, we got is unlikely to be correct. The odds of it being exactly 58.333% for the entire COS population seems like highly unlikely. Especially since I looked it up and like last year it was at like 67% for students in like that age range. Like apparently a lot of fucking students use the fuck out of TikTok. I used it for a little while. I didn't make videos, but I watched it and then I realized this thing just like a time vampire. It just fucking strains your fucking time away and nothing gets done. And you're like, I don't get 3 hours passed and I don't know what I did. I laughed and I enjoyed my time, but I couldn't tell you like maybe but 2 or 3 things I watched. So I'm like, nope, we're not watching TikTok no more. All right, so you don't want to do this shit by hand, do you? We're not gonna do it by hand. Fuck this. What you've been waiting for. StatCrunch commands. StatCrunch commands are, you've got some choices. We're gonna do 1 sample or 2 samples. And 2 samples is a later chapter. Then you're given a couple choices here. You're given the choice of data, summary. There's 4 choices, but I'm only going to list 3. You don't need the bottom one. Power, sample. Data means you need individual responses. Donnie says he uses TikTok regularly. Angel says she uses TikTok regularly. Melinda says she uses TikTok regularly. Maritza says she doesn't. Yeah, like recording different results.
Yeah.
Summary is like having what we had. 35 said yes out of 60. That's a summary. We have a summary of the data. You have X and you have N. Our sample, this is really, really useful for finding a good sample size based on your estimated proportion. This one's kind of neat. I'll show you how to do it. When you get there, when you do this one, you have to actually click on confidence interval width tab. And there you got to give it the CI as a decimal. So like if we wanted 95%, we'd say 0.95. You got to give it your p hat as a decimal. And you got to give it your width as a decimal. You print in these, like ours was 0.583. And we had 0.06. Nope, we had double that, 0.128 was our width, 2 times our error. If you put those in, it will spit out a good sample size. Ta-da! If you don't have a good estimate, no estimate, use p hat equals 0.5. 50%. Oh, damn. My wife made beans because they were nice and soft to eat. I had beans yesterday well, that was beans. This was probably yesterday's lunch coming through.
Oh, boy.
Yesterday's dinner. I had beans for lunch today too. So I'm like, I don't know what kind of beans they are, but she makes them with like, you like boiled, it's not refried. It's like boiled beans with like bacon and onions and shit in it. It's actually, it was good. Normally I'm like, come on, babe. Fucking wanting to make beans. She wants to make beans like every week. She's fucking a glutton for beans.
I'm a big fan of the kidney bean.
They're good in minestrone, but that's about it. Now, I like refried beans a lot. I don't want a fucking bowl of beans all the time. That's all she'll like have. Like, that's the entire fucking meal. Beans are good as part of the dish, but that's not all I want. That's what she does. She's like, let's do this all the fucking time.
Oh yeah, my grandpa he's lived off beef and rice like for decades.
It's a cheap way to live, but I mean, it gets fucking tiresome.
Oh,
Does, that's why I don't
that's my grandpa. He don't care. He wants it every week, every
My wife would do that. We have rice frequently, but it's usually not together. And it's usually not like flavored rice. It's usually like white rice or brown rice. And we throw something on it. Every once in a while, we'll have like a rice like mix. We'll make it with like chicken broth or something like that. Every once in a while, she tries to do like a Spanish version, but she doesn't have a good homemade Spanish recipe. So
It's like you basically just make like a tomato salsa and you throw it in brown rice. It's pretty much all the chicken.
she doesn't even know that. It's already bad enough. We got to eat a lot of beans. All right. Are you guys ready to look at some examples in the homework? There are, I think, 10 problems, and we're going to go over 4 of them for you. How about that? It's fucking awesome, right? Are you done, Angel?
Yeah.
Sure?
Yeah.
I can wait.
No, it's good, thank you, I'm just like.
We're going to do 1, 2, 3, and 5. Now, I did these with the morning class and I reset them, and so that they would have no data. I didn't get them wrong. Of course, I got them right. But unlike my midterm review, which wasn't 100%. Number 1, this is 9.1. Determine the point estimate of the population proportion. The margin of error for the following confidence interval. And the number of individuals in the sample with the specified characteristic X for the sample size provided. It says round to the nearest thousandth. So It says find the point estimate. Find the margin of error. And find X. The people with the trait. Number of people with the trait. Our given information. You know, the people that write this book, know that they're using StatCrunch for a lot of their students. Rather than fucking using the same terminology that StatCrunch is programmed to use, they fucking do this shit all the time. It says lower bound. When StatCrunch says lower limit, you'll see it in a second. Lower bound is 0.460. Upper bound is 0.910. And it tells us n equals 1000. That's the given information. And so part A, find p hat. It is important to know p hat is smack dab in the middle of the bounds. Right in the middle. So this is 0.46, this is 0.91. I'm not going to put the 0 at the end. I think they included the 0 at the end because they want you to round to the nearest thousandth, which is 3 decimal places. So maybe I'll do it. To find p hat, this is the midpoint formula. Midpoint formula for p hat. Lower bound plus upper bound divided by 2. .46 plus 0.91 divided by 2. P hat is 0.685. That'll answer A. We're gonna do them all right now. Let me pause, give you a chance to write that shit out, processing.
I have a glitch.
What?
I have a glitch with my processing.
Processing combat information.
Find it work.
So point estimate, just need like, midpoint pretty much.
When we have a lower bound and upper bound.
Oh,
Point estimate, what it means is we found this P from our sample and we're using it as an estimate for the population.
okay,
That's probably makes a little bit more sense.
yeah.
No, it's the upper bound minus P. It's a difference between, it's on the screen, it's,
But it's our estimated P, right?
yeah. We don't know what the real P is. But our margin of error is the difference between our p hat and our upper bound or our lower bound.
Oh,
You guys ready? Okay, she's done writing. Part B. Find the margin of error. Which is E. We said we could either do p hat minus the lower bound or upper bound. If I do, I think the lower bound is the easiest one to do because then I don't actually need the absolute value signs. This is 0.685 minus 0.46. And I'm getting 0.225. Doing that in my head, so maybe I better. Yeah, 0.225. You know what? I had beans for lunch today, and tomorrow my fucking college algebra students have a test. So it's gonna be all quiet, and there's a good chance they're gonna want the door shut so that the outside noise doesn't interrupt. So it'll be a self-contained environment
Oh, boy.
with Ode to Dave, fragrance of Dave.
Um,
All right, part C, find X. This requires you to remember what p hat is. P hat is x over n. So with a little bit of algebra, x equals n times p hat. For this problem, that's 1,000 times 0.685. And they usually choose n to make it really easy. 1,000 just means move the decimal place 3 times. And I get 685 as my x. All right. Everybody looks like they're done writing it. I'm gonna throw this shit in. Number 2. Construct a 95% confidence interval. With x equals 120, n equals 200. So they want the lower bound and they want the upper bound. I think I missed telling you something earlier. I totally did. Fuck the way to start this. Stats, proportion stats. Then one sample. My bad. That's David pulling a fucking fail. Okay. So stats. Proportion stats. One sample. We have summary. Wait, you guys are still writing? Put it back. Ready? Oh, wait, nope.
Ready.
I'm gonna make this a smaller window. That way, when I pop up StatCrunch, I can keep it open.
You gotta minimize that, cause I try to do it all the time and then it just erases my work and then it's like I have to log back in and all kinds of crap, so. So you just minimize the homework window, open up the stack.
I didn't minimize it, that just makes it go small. I just make it so it doesn't go full screen,
Yeah,
which is the box. That's minimized, that makes it go away.
yeah. Oh,
Here, you can put it up where it does split screen.
okay, yeah, yeah, sometimes it takes a lot of time.
So stats, proportion stats. One sample with summary. X is my number of successes. My observations is my sample size. We're going to be doing hypothesis testing in chapter 10 onward. For now, we're going to click on confidence interval. Check your percentage, make sure it's the same percentage they have listed. The default confidence interval is 95%. If it said 99%, we would change this to 0.99. That's all we need to put in. Gives me a lower limit and an upper limit. I'll write these down. It said to 3 decimal places, so I'll write to 3 decimal places. 0.532 and 0.66. It looks like I got to round up to 8. Notice it says that STD error. What is that standard error? I think that's number of deviation. I'm pretty sure it's number of deviations. That's close. Oh, wait. 0.6 minus. That is 1.96 times 0.0346. Yeah, that standard error is your standard deviation. So it gives us standard error. That's your standard deviation. Come over here and enter the lower bound and upper bound. I got 0.532 and 0.668. Next question. Okay, the next question is about the economic uncertainty. So I'm gonna give you the information that it gives. It says P is 66%. It says the error, margin of error is 3 percentage points. With a 95% confidence. They're gonna ask us to interpret whether or not a sentence makes sense. So we need to, like, let's state what the real statement of confidence is right now. The real statement of confidence should have something like this. We are 95% confident. We quote the percentage that they say. That the true proportion of people who agree is between. We need to generate the lower bound and upper bound here. Lower bound is 60, the P minus the E. 66 minus 3 is 63%. That's my lower bound. My upper bound is P plus E. 66 plus 3 or 69%. We are 95% confident that the true proportion of people who agree is between 63% and 69%. They will have some variation of this, and that will be the correct interpretation. It should list the CI percentage, the actual confidence interval, it should say what the parameter is that they're looking for, in this case, proportion. And it should say what the topic is. Without the topic, it's a meaningless sentence. All right, you guys ready to go over and look at the statements? So the first statement they give us is we are 95% confident that 66% of adults in the country during the period of economic uncertainty felt wages paid to workers in the industry were too low. So this whole period of economic uncertainty, that's my topic. They tell me the confidence level, the 95%. They don't this is clearly a proportion, but it's not an interval. They didn't give us a range. So this interpretation is flawed. There's no interval range here. And only one of these says that. The interpretation provides no interval about the population proportion. The next one says 92% to 98% confident. It looks like they took the 3 percentage points and applied it to the confidence level. That's not how that works. The confidence level is locked. What the margin of error goes with is the P. So they're saying that the interpretation indicates that the level of confidence is varying. It's somewhere in 92% to 98%. That's the wrong interpretation. That doesn't make sense. Oddly enough, it was B again. There's every single one of these is used in one of the answers. So they give you 4 sentences and they're like, which one makes sense? We are 95% confident that the interval from 0.63 to 0.69 contains the true proportion of adults in the country during the period of economic uncertainty who believe wages paid to workers in the industry were too low. They gave us their confident range. They gave us an interval. They told us the parameter they're talking about. And they gave us the topic. This one makes sense. It's a little different order than I said. I put the interval at the end, but it contains all the same information. And finally, this one says, in 95% of samples of adults in the country, during the period of economic uncertainty, the proportion who believe wages paid to workers in industry were too low is between 0.63 and 0.69. That's like saying they went out and did 100 samples and 95 of them came up with exactly 0.63 to 0.69 as their interval. That's completely unlikely. That's not what the confidence interval means. They're saying our confidence interval is dictating what the interval is for all the other population or samples. That's this description right here. It sets the standard for all the other intervals. It doesn't. It just means confidence interval means it will have the value in it. It won't necessarily be centered on it. And now we'll go on to chat number 5. Number 5 is on abolishing the penny. It tells us 99% confidence. It tells us the error is 3%. The margin of error is 3%. And it says what size sample should be obtained. So for me, it gives me A 96. Nope, 26. 26% is my p hat. B, it says no prior estimate. This is where we're going to do stats, proportion stats, one sample, power sample size. In it, we need our confidence level, which is 99% or 0.9. We need our target proportion. That's gonna be the percentages up here. It starts at 0.26 for the first one. It's gonna ask us for the width. The width is 2 times the error. So 6% or 0.06. And when we have all those, the size box is gonna be left empty. When we have for part, that'll do with part A. Part B, everything stays the same except we're gonna change target P hat to 50%. If you don't have a prior estimate, use 50%. And make sure you reset the width. You'll see what I mean in a second, but I want to let you write that down. We'll bust this out on the computer and then we'll be done. And you will be free to roam. Guys, ready? Close. Do not look at this crap. This is not going to be helpful. I already have StatCrunch open, so I'm going to come over and use it. We're going to go stats, proportion stats, one sample, power sample size. It starts off with hypothesis test power. We're never going to use that. Click on confidence interval width. Then we got to come in here and assign the levels that we had. 0.99 was the target proportion or confidence level. Target proportion was 0.26 and our width was 0.6. So this is what I drew on the paper without the box. I click compute and it gives me the sample size. 1419. Sorry, rounded. Then we do part B, no prior estimates. I wish they retold you it here. All it just says is n equals. You got to come up here and read this shit again. No prior estimates means we change this target proportion to 50. And notice how the width has changed a little bit. It's not 0.06 anymore. Change it back to 0.06. And now they give me a sample size of 1844. And that's it. That's all I got for you. GTFO, get the fuck out. Have a good evening. I'll see you guys on Thursday. It's Tuesday, right?
I don't even know anymore.
I recommend trying to do some of these by then. We already did 4 out of 10 problems. Try doing the rest before Thursday because we're doing confidence interval for means. And it's a lot of the menus are similar. If you get it a feel for it now, you'll be doing a lot better, so it'll make more sense on Thursday.
Don't get eating tacos.
It's just Taco Tuesday. God damn it, I bet she's gonna want me to have beans. She's like that.
I'm not too entirely impressed with the chicken soft tacos at Taco Bell. I just.
I like the Del Taco chicken hot taco.
Yeah, me too, they're delicious.
I don't know about Taco Bell, I can't remember last time I had them there. Oh, I said 66, not 68.
And I'm sorry, I didn't.
I wish you, yeah, I wish you said something.
I wish I would have too. I'm just not trusting my brain lately. And I was.
I'm gonna go back over here and change it like I had it right the whole time.
So sorry.
Yeah, that's all right, that's me fucking up.
Well, it's me too for not being, you told us, to speak up. I just like all day and I just like it gets myself.
Did I stop recording? Let me stop recording. It's okay.